Hello, welcome back to physics. In this lesson, we're going to conquer the topic of what is acceleration. So our roadmap is we've talked about displacement and distance. We've talked about velocity, both average velocity and instantaneous velocity. Here we're going to conquer the topic of actually what is acceleration conceptually and from a unit point of view. Next couple of lessons, we'll talk about average acceleration and instantaneous acceleration. So we're kind of marching down the exact same path we did before for velocity, but here we're going to conquer acceleration. Because in order to predict where a ball is going to land, we have to know where it starts from, that's the initial position. We have to know its velocity, so we talked about velocity, and we have to know how it's accelerating. In other words, is it speeding up or slowing down? And so we're going to conquer that here, and then we'll be able to solve the equations that predict where things are going to go. That's our goal. So in this lesson, we're not going to do any equations. We're just going to talk about what is acceleration from an intuitive point of view, and you already know what acceleration is. You're in a car, you're at a red light, you step on the gas, you're pushed back into your seat, and you accelerate. You already know what that means. Acceleration, in a nutshell, is when you speed up your velocity. Right? When you're starting at a certain velocity and you increase that velocity so it pushes you back in your seat, that process of speeding up is what we call acceleration. Now in everyday language, we also use the word deceleration. Deceleration is when you hit the brakes, you're thrown forward, and because you're slowing down. So acceleration, we say we're speeding up. Deceleration, we say we're slowing down. In physics, we don't really use the word deceleration. We just say you have a positive acceleration, meaning you're speeding up, or you have a negative acceleration, which just means you're slowing down. So acceleration, deceleration really just get used. The word acceleration is what we use to describe both of those. All right, so let's kind of step back and discuss acceleration by going down memory lane just a little bit here in the beginning. So we talked about the concept of displacement. We talked about that quite a bit. And what were the units of displacement? Well, displacement is basically distance in a certain direction, how far away from the origin we are, right? So we use the unit of meter for that, all right? And then we talked about the concept of velocity. So we're reviewing things here. We talked about the concept of velocity. Both of these are vector quantities, and the units of velocity we already know is meters per second. That means every second that goes on, I travel so many meters down the road, meters per second. All right, now we're finally going to tackle something new. We're going to call it acceleration. Now, I need you to kind of see the pattern here. When we look at distance and we say, how much is our displacement? We say, how much is our displacement changing with time? Then we get to something we call velocity. So you can kind of say that you go from the displacement into talking about velocity by looking at how it changes with respect to time. So I'll just put delta t to tell us that we're looking at how the displacement changes with time. That's what this is saying. And then we arrive at a new thing that we call velocity, right? So what we're going to do next is we're going to look at the velocity, and we're going to say, how does it change with respect to time? How does the velocity change with time, right? And that is what we call acceleration. And the unit of acceleration is meters per second squared. Now, so you start out with meters in terms of displacement. Everybody understands that. And then you talk about velocity, meters per second. Everybody understands that because it's how far you're going every second. But then you get to acceleration and you have meters per second squared, and people lose their mind because it doesn't make sense. What is that squared there? What does that mean? Okay? So we're going to start this section by just talking about the units, explain what this means, and then we'll do some quick little examples to show you how to use acceleration. And then we'll move on to more equations later. So instead of thinking about this as meters per second squared, start to think about it like this. Think about it like this. Think of the following. Instead of meters per second squared, think of it as meters per second on the top of the fraction, that's a velocity, per second. In other words, don't think of it initially here in the beginning as meters per second squared. Think of it as meters per second per second. That's what's going on here. This guy right here is how much velocity, that's VEL, velocity, I gain. And this guy on the bottom is per second. So you all know intuitively, because we ride in cars and trains and airplanes, you know that the concept of acceleration is when you're pushed in your seat because your speed is increasing. I mean, I can go down the road at 100 miles an hour, constant speed, no acceleration. I'll be going really fast, but I'm not going to feel anything in my seat, because if I'm going 100 miles an hour at a constant velocity, then, you know, I'm not really pushed anywhere. But if I step on the gas and push myself in the seat, I'm increasing my velocity every second. So every second I increase my velocity. Another second goes by, I increase my velocity again. Another third second goes by, I increase my velocity yet again. Every single second, my velocity goes up, 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 increasing every time. That means that every second, my velocity must be increasing. Acceleration is telling me how many meters per second am I increasing every second, because the velocity, the concept of velocity is meters per second. So when you write it as meters per second, you're saying how much velocity am I picking up every second that goes by, right? So that's why I wanted to start at the beginning with displacement. Okay, we'll see how that changes with time. We get meters per second. We see how that changes with time. We get meters per second. Now from algebra, you know that when you have a fraction like this, a fraction on top of something else, this meters per second, you can drop that second s down there, and that's why it becomes meters per second squared, because the meter per second, the second part from the top, can be dropped down to the denominator, multiplying and giving you s squared. So when you see meters per second squared, in the beginning anyway, when you're just new to physics, don't think of so much of like, oh, that's a crazy unit. Just think that's meters per second per second. It sounds weird, meters per second, but that's exactly what it is. So in order to solidify this in your mind, to make it absolutely concrete, let's do a really quick little example. We'll do it right here on this board. We'll do a really quick little example. So let's say I start at 10 meters per second. That's my initial velocity. So the way I'm going to write that, and you're going to see this in physics, so you might as well get used to it. My initial velocity, I'm going to call it V naught. That's a sub-zero, or sub-O, actually, is 10 meters per second. So I'm giving you like a mini problem. It's not a full-blown, fully baked problem, but it's very good to do this kind of thing. Let's say you start out at 10 meters per second. In physics, we don't really write it out, I start at 10 meters per second. What you see is V naught is 10 meters per second. You can think of the naught as like a sub I for initial. So some problems might tell you your initial velocity, V sub I, is 10 meters per second. Some books, most books, will say V naught. Naught is kind of like the initial condition. It's the initial thing that happens. So we're just saying we're starting at 10 meters per second when I start the clock and start looking at what happens. And then let's say I accelerate at what? At 2. To what? What's the unit of acceleration? It's meters per second squared. So I write that as meters per second squared. So when you see meters per second, you know it's velocity. When you see meters per second squared, you know it's acceleration, even if I don't write this, okay? So I'm going to give you these two things, and let's take a look at what's actually happening as time goes on, because that'll give you a really good feel for what the concept of acceleration really is. So then we say, what is going on at t is equal to 0 seconds? Right? What's going on at t is equal to 0 second? Well, we'll fill in the chart in a second. Let's look at t, 1 second, then we'll look at 2 seconds, then we'll look at 3 seconds, and we'll look at 4 seconds, and we'll look at 5 seconds in the future. So we start the clock at 0 seconds. That's actually why it's called V naught, or V sub 0, because it's what's going on at time 0, right? And then what we already know from this is 10 meters per second. So let me go ahead and draw a little table here. And we'll do it like this. So at this time, the velocity is 10 meters per second. This is just given in the problem statement. This is nothing crazy. This is just given in the problem statement here. So my question to you is, if I start out at 10 meters per second, what's going to be my velocity in 1 second in the future? Right? Well, you know the concept of acceleration is what? It is how much velocity I'm picking up, or increasing by, every single second. It's meters per second, okay? So 1 second in the future, since I'm accelerating at this rate, 1 second in the future, I should pick up 2 meters per second. Because every second I'm increasing by 2 meters per second. So what this means is that at 1 second in the future, I'm actually going 12 meters per second. Because in that 1 second that elapsed, I picked up 2 meters per second. You see, my rate was 2 meters per second. Every second that goes by, that's how much my speed increases. Now, when I move from 1 to 2 seconds, that means I'm now going 14 meters per second because I picked up another 2 meters per second. Then I go another second in the future, I'm now traveling 16 meters per second. Then I travel another second in the future, I'm going 18 meters per second, and you see the pattern, and then I'm going 20 meters per second. That concept here, this concept that I'm writing out in numbers with a real example, gives a lot of students tons of problems with acceleration because in a second you'll see we'll talk about positive acceleration, we'll talk about negative acceleration, and it gets confusing, but even the concept of what it is difficult for a lot of people to understand. It is no more complicated than what's on the board. All it means is, just like velocity means, every second that goes in time, I'm picking up that many meters. That's what velocity is, how many meters per second. And acceleration is the same concept. Every second that goes by, how much faster am I going? How much faster am I going? In this case, it's 2 meters per second, so every second that goes by, my speed increases by 2. That's what that means, or my velocity increases by 2. Now graphically, we can do something interesting just to kind of show you what this means. So here I'm going 10, then 12, then 14, 16, 18, 20. So if I'm actually doing this, I'm going to be pushing my seat because I'm increasing my speed constantly, basically. But if you look at it, you know velocity is a vector, so I can write it as an arrow. So just underneath it, let's draw this as an arrow. Let's pretend 10 meters per second looks like this. Right, that's the velocity vector. So it's an arrow to the right, like this. Well, 12 would be an arrow that would be slightly longer than that one. And 14 would be an arrow slightly longer than that one. And 16 would be an arrow slightly longer than that one. And you get the point here, longer than that one. And this one's even the longest one of all. I tried to draw them. This one's not quite so clear, but anyway, you get the point. A little bit longer each time. And I can draw my little V's under here. You know this basically is representing velocity in each of these cases. All right, why am I doing this? Because I want you to get a visual representation that this vector is increasing its length because I'm increasing the magnitude of the vector every time. Now let me kind of summarize all this kind of thing in words. So take this in your mind and follow me over here as we write down a few words. When I have a positive velocity, in general, what does it mean? I told you many times, if you have a positive velocity, it means you're moving to, I'm going to call it to the right, but really what I'm saying is you're moving in the positive x direction. Remember I said the sign of your velocity is not like a crazy new dimension or something if it's negative. It just means positive means going in the plus x direction, negative means you're going the other way. So when I have a positive velocity, it means I'm moving to the right, which means towards positive x. Now you can see from the problem below that if I have a positive acceleration, what does it actually mean? It means I'm increasing. I'm increasing my velocity every second. Every second, so I have a positive, in this case, positive 2 meters per second. Because it was positive, that means my speed is increasing every second. So it went from 10 to 12 to 14, 16, 18, 20 because it was a positive 2 meters per second squared. If it were negative here, it would do something different we'll talk about in just a second. But I want you to see the pattern. Positive velocity means moving to the right, increasing x. Positive acceleration means I'm increasing my velocity every single second. So let me switch colors over here. And let's talk about this. Now, if I have a negative velocity, what does that mean? Negative velocity means I'm not moving to the right, I'm moving to the left. We already said that in words a few minutes ago. So positive velocity to the right, negative velocity moving to the left. Let's say what is going to happen when I have a negative acceleration. This gives many, many students problems. Well, if a positive acceleration means I'm increasing my velocity every second, a negative acceleration, I already kind of gave you the punchline when we opened the lesson, it just means you're slowing down, you're decreasing your velocity. It's what we commonly call deceleration. So we never say in physics you're decelerating at a rate, well you might see it, but typically we don't use that word. We just say you're accelerating at -5 meters per second squared. It means you're slowing down. That's how we keep track of speeding up and slowing down, by using the signs. So this means decreasing my velocity every second. And we call that commonly deceleration, all right? So the reason I'm bringing up the signs here is because I want to do a couple more quick examples just like this. Very simple things where I'm going to give you a starting speed and an acceleration, and we're going to predict in the future what your velocity is actually going to do. And so we're going to see the pattern here. So let's go and do that right now with our very next guy here. I'm going to give you the following information. V naught is 7 meters per second. Again, this means initial velocity, or you can think of it as velocity at time 0. That's what it really means, 7 meters per second. And I'm going to give you that the acceleration, A, is typically how it's written, is negative 3 meters per second squared. So again, a lot of people look at this negative and they start immediately getting confused. What is meters per second squared? What does the negative mean? Well, we go back up here and we say, well, a positive acceleration means I'm increasing my velocity that much every second. And a negative acceleration just means that I'm decreasing my velocity that much every second. So what this means is I'm not increasing by 3 meters per second every second. I'm actually decreasing my velocity by 3 meters per second every second. So if we build the same exact chart that we did a second ago, what you're going to get is that t is equal to 0. You're going to have a velocity of what? We started out with 7 meters per second. So let's go build this quick little chart. So then we're going to have 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. We're only going to go out a little ways here. All right, so I'll switch colors, and we'll do it in red here. So we're decreasing our, well, let's put it this way. We're accelerating at negative 3 meters per second squared. We started here 1 second in the future. What does it mean? It means 7 minus 3 is 4. So that means you're going 4 meters per second now. Because that 1 second that elapsed means I took off 3 meters per second from my velocity. And then I go another second in the future, and now I'm traveling 1 meter per second because I subtracted 3 again. You see, this is simple math. Then I subtract 3 again. Now here's where people go kind of nuts sometimes. They say, well, I was going 1 meter per second, and now I've got to subtract 3. What is that? Well, you just do the algebra. 1 minus 3 is what? It's negative 2 meters per second. Because remember, negative velocity shouldn't freak you out now. Negative velocity just means I'm not going that way anymore. I'm actually going that way, right? Because positive is that way, negative is that way. Then what happens here? I subtract 3 again. It'll be negative 5 meter per second. Subtract 3 again, negative 8 meter per second. So let's go and quickly draw our little pictures. Remember in the first one, we were increasing speed the whole time, so I drew these arrows longer, 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 longer. Well, now we're going to do the same thing. We start out here with our kind of vector representation, 7 meters per second is a pretty long arrow. But then the next second, I'm still going that way because it's a positive velocity, but not quite as fast. That means here, I'm actually going a little bit slower. Still in the exact same direction, though, because they're both positive. Here, I'm still going positive, but I've slowed down quite a bit, so this is what we're calling 1 meter per second, positive. Then what happens here? Crucially, now I've turned around. I'm no longer going that way. I'm actually going that way, and it's a larger magnitude than this one, so it'll be something like this. Trying to do my best here. So this is this long. This should be slightly longer, and not as long as this one. But it's crucially important for you to understand that now I'm suddenly going the other direction. And then negative 5 will be longer. It's not quite long enough, probably. Something like this. And then negative 8 is actually even larger than the 7 that we started with, but it's actually going the other way. So it should be a longer arrow than this. I'm actually going to run out of room, probably. Let me do it down below. It'll be something probably like this. Yeah, because I ran out of room. But you get the point. It's slightly longer. I'm trying to draw it longer. Apologize if I can't get there. Something like this. The details of how long the arrows are is not critical. What I want you to understand is that positive accelerations just means you're adding velocity every second. Plus, 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 plus. So you generally go faster, faster, faster. Okay? Negative accelerations really follow the same pattern. You're still adding the acceleration, but you're just adding something that's negative. So what ends up happening is you subtract it every second. So every second, that's why we call it deceleration, because you're slowing down. So you can think of it as slowing down, or you can think of it as just adding a negative number, adding a negative acceleration, right? So you can think of, this is kind of important, I want you to see. We started at a velocity that was going this way. I was going fast, and then I slowed down, and then I actually turned around, and then I start going faster the other way. So see what happened? Let me do that one more time. Faster, slow down, and then I turned around and I accelerate back the other way. So you can think of, this is important, I wrote this in my notes and I want to make sure you internalize it yourself. Positive acceleration you can think of as speeding up in the positive direction. That's exactly what we're doing here. We're speeding up in the positive direction, positive acceleration. Negative acceleration you can kind of think of two ways. It's exactly the same thing, but you can think about it two ways. You can think of it as slowing down in the positive direction, like we think of decelerating in a car. But this example here kind of illustrates that kind of a better way to think about it is that a negative acceleration really means you're speeding up in the opposite direction, in the negative direction. So positive acceleration means I'm speeding up this way. Negative acceleration means I'm speeding up in the reverse direction the other way, because you can see what happens. See, in a car, it's a little bit misleading because in a car, when we say we decelerate, we slow down, and we do decelerate, that's all correct, but then we stop. Usually you not turn the car around, because when we turn the car around, we accelerate the other way, we say we're accelerating again. But with a baseball flying through space, or whatever this thing is we're drawing here, we're decelerating, or we're accelerating negatively the entire time. Our speed is decreasing, 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 but then finally, because we subtract again, by subtracting it again, we end up turning around and going the other way. So you can think of this negative acceleration in two ways. You can think of it as slowing down in the positive direction, which is true, but you can also think about it as every step along the way, I'm really accelerating negatively. So I'm accelerating negatively here, making the arrow shorter. I'm accelerating negatively here, making the arrow even shorter. I'm accelerating negatively here, making it larger, larger, largest. Because every step of the way I'm adding that -3. So it's just kind of like they're exactly the same thing, but I prefer you to think about a negative acceleration, meaning that instead of thinking of slowing down all the time, just think of it as I'm speeding up in the negative x direction. Here, that speeding up in the negative x direction just shrinks the arrow until finally I have no arrow left, and then I reverse, and now here you can easily see it accelerating in the negative x direction once I've turned around. So given that, let's do just a couple of quick other ones. After all that talking, this will be much, much easier. So now I'm going to give you the following information. I'm going to give you an initial velocity of -3 meters per second, and I'm going to give you an acceleration of 1 meter per second squared. This is where the wheels come off the car a lot of times with students, because they understand the concept of acceleration because we drive cars, but then when you give them negative accelerations, or in this case negative velocities, and then positive accelerations, it's like very confusing in your head what's going on. What this means is I actually start off going this way, but I'm actually speeding my velocity up in this direction every second. So looking at it as a table, at t is equal to 0 seconds, my velocity is -3 meters per second. Now let's go look at a few times in the future. Well, 1 second, 2 seconds, 3 seconds, 4 seconds. We'll just take it to 4 seconds this time because you'll get the point here. All right. Now you follow the rule. It's exactly the same rule. I have some speed, and every second that goes in the future, I'm just going to be adding my acceleration. My acceleration happens to be positive, so I'm going to be adding 1 to it every time. So what is -3 plus 1? It's going to be -2 meters per second. What is -2 plus 1? It's -1 meters per second. What is -1 plus 1? Well, that's going to be 0 meters per second, so it looks like I've stopped. And then finally, what is 0 plus 1? It's 1 meter per second. And if you wanted to draw that in our handy-dandy little thing here, -3 would be a vector that kind of looks like this. It's that way because it's negative. -2 would be also pointing this way, but shorter. -1 would also be pointing that way, but even shorter, right? 0 would be a vector with no length at all, so I'm just going to put a dot. It doesn't point anywhere, but well, it has a length of 0. And then over here, I'm going to be 1 meter per second, again, the exact same length as this one, but pointed the other direction. So you can see what happens is, I'm starting out by going to the left fast, but because I'm accelerating in the positive direction, I'm adding velocity opposite to the way I'm initially going, so I'm actually slowing down in the negative sense. I finally get to 0, and then I finally start kind of going forward in the positive sense. So again, positive acceleration is consistent with our definition. It's just adding positive velocity every single second. Every second I'm adding positive velocity. That just happens to slow me down. Eventually I turn around and go the other way. Let me give you the final problem. This is the one that usually gives people tons of problems. Let me give you the following problem. It's not going to give you any problems because you understand it now. What if my initial velocity was also -5 meters per second, but my acceleration is now given as -2 meters per second. So this again gives people meters per second squared. It gives people a lot of problems because your velocity is backwards and your acceleration is backwards, so you seem to be doing a lot of mental gymnastics. But then you just follow the kind of the idea behind it. If you're at 0 seconds and my initial velocity is -5 meters per second, let's do a quick table. We're just going to do 1 second, 2 seconds, 3 seconds. We'll just do 3 seconds. We don't need to do so much now that you understand what's happening. So what's going to happen here? Every single second along the way, what am I doing? I'm adding velocity, but in this case, my acceleration is -2 meters per second, which means that I'm really going to subtract 2 meters per second every second, or I'm adding a -2, which means I'm subtracting 2 meters per second every single second. So I need to add -2 to this. What's going to happen? I'm going to add -2 to this. I'm going to get -7 meters per second. But then I'm going to do it again. I'm going to add -2. That's going to give me -9 meters per second. And then I'm going to add -2 again. That's going to give me -11 meters per second. So if we're going to draw our handy little thing, we start out going negatively 5 meters per second. And then later on, we're going 7 meters per second. Later on, we're going even more, 9 meters per second. And later on, we're going 11 meters per second. Of course, these are my velocity vectors that I'm kind of drawing in the x direction, the negative x direction. But notice I never turned around. Why did I not turn around? Because I'm already going to the left, and this is telling me that I'm basically, if it were positive, I would be adding positive velocity counteracting this, but I'm adding negative velocity, which means again, I told you to start thinking about negative acceleration. Instead of thinking about it as always slowing down, just think of negative acceleration as speeding up, but in the negative direction. So if I start here, if I'm going to speed up in the negative direction, of course my arrow is going to get bigger, bigger, bigger in the negative direction. That's what this problem is trying to show you. So this was just an introduction to what is acceleration. I wanted to introduce it in terms of units. The big, big picture takeaway is that we've talked about 3 main concepts in motion so far. Displacement is how far away you are, it's meters. When we look at how it changes with time, we get meters per second. When we look at how the velocity changes with time, we get acceleration, meters per second, or the way you write it is meters per second squared. So now that you understand what it's doing, that every second that you accelerate, you're adding so much velocity every second. In the next lesson, we'll talk about average acceleration and how to calculate it. It's going to be very simple, very much in line with what we talked about here. And then we'll talk about instantaneous acceleration, which will be very familiar with what we've also talked about in the past. Once we have all those blocks in place, we'll be able to actually solve problems with motion in one dimension, moving things up and see where they're going to be down the road, down in time, because we'll then know the displacement, we'll know the velocity, we'll know the acceleration, and we'll put it all together to predict where a ball or whatever will be sometime in the future.